Engine fire right-hand side, Captain.
The words every pilot hopes he never hears. Fortunately, these pilots are hearing them on the ground in a state-of-the-art flight simulator. What makes this ride so real even the pilot sweats? The answer comes from the cornfields of Kansas. In a hangar at the Lawrence Municipal Airport, engineers for KSR, Kohlman Systems Research, are digging deep into the guts of this business jet.
Try it again!
With miles of orange cable and hundreds of mechanical and electric sensors, they're literally taking the pulse of this plane in the hangar and then in the air during 70 to 100 hours of flight maneuvers. These KSR engineers are on a mission to find out how this particular Hawker 800 XP performs so future pilots will get the most realistic training possible in the safe confines of a flight simulator.
As the nose wheel rotates right to left, it will basically shorten or lengthen this cable. That'll change the resistance of the sensor, creating a voltage that we can measure on our recording equipment.
The data KSR collects during weeks of flight testing will end up at companies like Simuflight in Dallas, home to some of the most advanced flight simulators on the planet.
You do find yourself getting lost in the fact that, yes, I know it's not real, but it sure feels real, and that's the whole purpose. I mean, we're trying to fake out the pilots and give them all the cues that they need so that when they do get in the actual aircraft, they can do it and they'll be able to respond to it.
To get this level of reality, KSR collects reams of information on aircraft instrumentation and aerodynamics. Since 1982, the company has become literally a repository of flight data on more than 70 different types of aircraft.
I mean, we've actually done data collection over that period of time on more airplanes than Boeing has, than Airbus has, than anyone has, because we've flown from the C-5, the super transport plane for the Air Force, the AWACS, down to a little twin-engine Piper Seminole. So we've collected data on literally everything.
As president, KSR's Tom Rawlings has seen the company's range of services and professional relationships grow exponentially since he came on board in 1993.
Good range, good elevation.
By the mid-90s, the company was so well known and respected that the Air Force commissioned KSR to gather flight test data for air-to-air refueling operations. Now pilots can train for these delicate in-flight maneuvers without leaving the hangar. But that kind of project and respect didn't just happen for KSR.
Early on, we had to take our instrumentation and put it along with some of the manufacturer's instrumentation and compare the data that they were collecting to the data that we were collecting. And we went through that process and provided that demonstration to the FAA, and they say, hey, this is equal, if not better, because it's very focused on what it's for.
KSR's focus on data collection began in a classroom on the campus of the University of Kansas. 20 years ago, professors David Kohlman and William Schweigert were teaching a class called Flight Test Principles and Practices, a continuing education program both still teach to this day. Their class attracted many up-and-coming engineers who were trying to build better flight simulators and had no idea how to collect data for the burgeoning business jet population. Schweigert, a senior scientist for NASA's Dryden Flight Research Center, knew he and Kohlman could help.
It was what we call today out-of-the-box type thinking that made these things possible. And I was never surprised. To me, it was a matter of doing what I had always dreamed could be possible and making it successful.
From its work on flight simulators and data collection, KSR has spread its wings to other key areas of the aviation industry. KSR is a leader in supplemental type certification, providing data to the Federal Aviation Administration on planes modified from their original design or flight purpose. And with more air traffic crowding the skies, KSR is helping planes fly closer together at high altitudes, within 1,000 vertical feet of one another.
Certifying authorities, government authorities, want to be able to increase the capacity of airspace, and they're wanting to be able to put airplanes closer together vertically. And but before they allow that to happen, you've got to demonstrate that the height-keeping equipment and instrumentation on that airplane are adequate, that the margin of safety is there.
To accomplish these tests, KSR engineers place another of their flight test equipment designs, what's known as a trailing cone on the back of the aircraft, to measure the true source of pressure altitude. KSR engineers travel the world with equipment that has become increasingly more portable to get the job done at virtually any location, from Kansas to Canada to Korea.
We allow our engineers really to see a program from start to finish. A lot of what we do is strong in theory, so it's a technical challenge. You need a strong theoretical background, but it's also hands-on. Our guys work with real airplanes. We have real airplanes around. And so you can really see the full range of that engineering service. And I think that has been very rewarding. And that combined with the variety of programs that we work on make it an interesting place to work, and one that I think gives people enough technical challenge that they're looking forward to the next program.
With the constant addition of computers into nearly every aspect of the aviation industry these days, aircraft data collection and flight testing are certain to become even more complex. But with a solid history of out-of-the-box thinking, there's no doubt the team at KSR will be up to the challenge.